conversation for the day is going to be on large language models on the DataScale SN30s. So with that in particular, let's see if I can go to the next slide. So in particular, we're going to be looking at a model box of Llama 13B in our example. With the greatness that we kind of already showcased with model boxes, that we've taken care of as much that can be, and still have the users control their input, their data, being able to perform pre-training, fine-tuning, and inference still. Some of the point of our conversation today will be how we leverage essentially wrapper scripts that have already been developed and released and are maintained just for Argonne National Lab for ease of use. So an overview of our Llama 13 model box here. We essentially have our Llama 13B SambaNova implementation, and we have a model box image that has a lot of the things, like everything that's needed to actually run and be successful on, while still maintaining what that unique user perspective and use. So here there's 4 things that the user has to provide and is responsible for to be able to use these scripts successfully. Basically, unique parameters for the runtime configuration, which we do already have like defaulted into the script, but essentially what that user wants to change to impact certain results and really make it like their own. The checkpoint, which for this particular model, Llama Hugging Face checkpoint that basically includes a tokenizer that helps maps the data to the conversion to be able used for the model. Next is our data, basically data in HT5 format. We will basically cover essentially how you take your raw data and turn it into that. And then lastly, the output locations if you're using just the default scripts. And I've prepared a little bit of a mock demo to help illustrate some of these points. So this is not on an ANO system. You'll notice some differences, such as like how my username is set up and the number here. But this is essentially what we call our CE nodes, node 2. And we maintain this to an impeccable degree of mimicry to what's used on ANO systems. So that way we can best support and test anything that we work on, develop before it ever has to touch ANO system. And this is actually some of the support scripts that we've developed and support with ANO. There's something approximating 30 to 50 models here. You'll notice we have our Llama model boxes over here, and they encompass a lot of things past just LLMs. Basically using these are very, very easy. And I'm going to just kind of show you how easy that is. Just so it can run in the background for the rest of the presentation. You can basically use the script as is, give it certain user parameters for how many nodes you want and where you want the results to be. And then I've essentially made a copy of those scripts into my custom Scratch directory and made some changes to run. Oh no. And I forgot to add the pre-training to this command. There we go. And so I'm gonna let that run in the background while we do the rest of the kind of walk through what's actually happened here and some of the changes that were made and how I'm basically making this work for myself. So going back to our wonderful tutorial. So just to quickly let that run. Let's see, is there anything else I want to talk about here? I don't believe so. So let's focus on the details on the user provided information. As we kind of already got showed in our last picture graph showing some of these advantages, here's a kind of a deeper breakdown of what those details actually mean, such as essentially the wrapper scripts have certain execution defaults that are provided, but they can be changed, such as parameter and hyperparameters for that user's particular run. Basically, the correct checkpoint, which basically includes a random initiation of the weights, as well as tokenizers for the tuning and inference, which will go in much greater detail later on. We have essentially the example data sets that are already on your system for you to use, as well as how you would prepare your data for specific use cases. And lastly, just kind of run down like the output information, and I'll show that as well with my script demonstration. Um, so the big things that we're going to be focused on now are basically the scripts, again, just for 13B. Let's see, basically, so basically these 5 scripts. As you can see here, we have two scripts for our pre-training, a setup and a run, 2 scripts for fine-tuning, and 1 script for inference. And so that will be the focus of our talk today. Some of the things that you can change within pre-training are batch size, workers, learning rate, schedule, weight decay, and warm-up. For inference parameters, you can change a host of the sampling parameters as well as seeding. And lastly, the logging checkpoint frequency, depending on how long your run is, you can do as much logging as you want. You can do it less so, and I can show examples of what that looks like a little bit later on. All right, so one of the key things is that you have a necessary tokenizer uh, that has the weights for the model to build, and these will be grabbed from Lob and Hugging Face and have a common location where they can be used. Um, their example structure looks something of the effect of this. Um, where you have your added tokens. You have basically a combination of binaries and JSON. Um, the most of the items in here are binaries that basically show the model's construction and the configs of the model. And you can look into those, look at the configurations, have a better idea of essentially what the model expects, which is one of the key responsibilities of the user. And probably one of the most important things, the tokenizer.model, which is what we're going to use to be able to actually implement this on the system. So just a brief conversation as far as the data sets that are basically preset to be used at the various points. An open web text, which has been a collection of basically Reddit comments with a certain number of upvotes that have been basically pre-cleaned to have pre-cleaned and used that makes them key for prompt and completion tasks and for pre-training web open work. For fine tuning, basically a superglue 2 is used, which is basically a robust collection of data that's basically been used as like universally recognized benchmark for a number of papers and other considerations that show that you essentially can't game this data, that a model that can perform well in this task can be used for a midget of other tasks not related. And lastly, we do have some provided generated prompts you can use for inference, and it's also very much encouraged that you should to use your own here and to take advantage of models from that you fine tune or specific for yourself. Um, all right. Here, I basically want to highlight the preparing of a custom data set. So again, one of the biggest responsibilities on the user is actually preparing their data. And that can be at best of times a very time consuming process. Um, and so we've done our best to make it easy by having this publicly available package called Generated Data Prep that can take raw and structured text data in Excel as PDFs, docs, or text, and be able to generate that into a JSON object, which taking a JSON object and turning that into a HTML5 file is a much easier feat than taking the raw data and turning it into a JSON. And just kind of see the JSON format here that the model would expect before it's been encoded is we have a English prompt here and we have its completion. And then for our HDF5 data files, We have essentially a coding, which is a sort for high distribution file system that is the most efficient way for the model to basically read, analyze, and use that data while it's running. All right. Just as the Again, the general data prep tool is a publicly available repo, but just as a quick aside, as far as my recommendation for using it, since I didn't see that in the documentation when I've used it in the past, is essentially after you download it, create your virtual environment around it, work from the virtual environment, install the necessary packages, and then if you want to verify that everything's installed properly and ready to run for your specific data use case, then you add the pip install of the requirements, and then you can do a quick PyTest. There's about 100 tests that it'll go through and verify. Um, and just again highlight essentially the expected data format from basic JSON HTF5 files, a prompt, a completion, and it can be done in various formats. Some easier to work with than others. Here's just basically an example showing what that would actually look like from your command line. Just once you have that package installed, Python 3, generate data prep pipeline, you need to specify your input file location, your output file location, what type of tokenizer you're going to be using, your expected sequence length. One of the really great advantages with this is that no matter what the sequence lengths of that you're input into it, as far as from the text side into the JSON, even if it's shorter than a sequence length of 496, it basically turns every single encoding into a max sequence length of 4096. Um, for this model, you can use different sequences for different models, but for our Llama 13B that I'm using an example a day, it's expecting a max sequence length of 4096. Some of these other parameters here essentially just involved. So how do you pack and make those tokens? And then they are essentially if it can be done within a compute like your local computer, or if you need to do it from an external file system. See here. And this is just another detailed example. I'm not really going to talk about this much right now, but this is a great reference point for when you're actually doing the work yourself, because the details of this encoding are really important. And it's honestly where you'll spend most of your time, in my experience, when preparing to work with these models. One thing I did want to highlight here is that if you didn't have enough data, is essentially the pipeline won't work. And that can be very frustrating if you're not basically aware of that. And so there are different pipelines of work that you can go through to basically synthesize more data if you don't have enough. And essentially some techniques and troubleshooting that you can do to actually make sure that you get that data where it needs to be used by the model. All right, user provide details. If using the wrapper scripts, we essentially have our kind of default locations that you can expect from the scripts, and I can look at those in detail together as far as highlights some things. Um, a lot of your output directory can be expected within this location. And then it will basically look something of this effect. Can take up a lot of memory. Um, and the with the distributed file system that you can find on the system, you have terabytes of data available, and you have a certain quota that's been granted to you. If you exceed that quota, you either basically need to get rid of some X amount of things or request from A&O to have a larger quota. And let's just quickly check in on this. Some of the ways that you can actually look at the outputs. So if you notice here, this is actually slightly different. So, and as far as just the results directory, and this is referred to in the output path, and that is literally just for Slurm. And while it's been running, basically this just shows me the submitted job, uh, the the batch job number, number of nodes used, the number of RDUs, and the number of tasks expected. And you see here it's being used here, and it looks like I unfortunately had something come up during the job. So, which is unfortunate. Luckily, I did prepare some other stuff in advance. So we are going to proceed as if everything's working. Since it's hard to troubleshoot and give a presentation at the same time. That's okay. Details on wrapper scripts. So the wrapper scripts for Llama 13B monologues. They are very similarly structured, and that was done by design. They have a uniform structure that essentially, once you become accustomed to using one of these wrapper scripts, you've pretty much empowered your knowledge to be able to use any of the other ones. Uh, so we'll kind of like highlight some of the differences between them, and I will actually take this moment to kind of look. I want to take this moment to look into this. Yeah, I think I will, just to give it hopefully a little bit better context. So just to quickly look at some of these scripts. This is basically a setup script that's part of the automatic Slurm integration. So, you know, essentially it helps us be able to automatically control the number of nodes. That's what the first argument's for. If there's not if there's not an argument passed, it will automatically use one. And then our second argument will be an output location. And if that output location is not specified, an automatic date will be created. And then for the user, as far as the biggest thing kind of need to be aware of is your number of tasks asked of it, the number of RDUs that you're asking for, as well as the place of the run script. If you basically use the scripts unchanged, this will be data ANL slash scripts, the name of the script. And here I've changed it to run uh, from my custom script. Uh, doo -doo -doo. And you'll basically notice a very similar structure to these and the other ones. And this is what this slide's basically talking about here is essentially what it does and some of the distinctions. But this submits our pre-training job to Llama uh, using the open web text data set on Slurm, using that SBATS command that I just highlighted. Our fine tuning is actually what does our S run with the Slurm integration. It takes advantage of the Superglue 4K, Superglue 2 4K dataset. It also has the parameters related to the bindings of our singularity image that is provided as part of the model box, as well as the Python command that actually executes the model. And then inference. The inference is specific as far as your either unique prompts or the provided SambaNova prompts to get started. It's also basically very easy to be able to change the checkpoint path to use checkpoints that you've generated and to work from those. So wrapper script difference for Llama 13B model box. So since I've already kind of talked about this a lot, we can use this as a referral point when you're looking at yourself. Example pre-trained from the scratch run command. And I already showed you guys kind of how this would actually work, and what you can expect from it, the optional arguments that are required, and then what it would basically kind of look like if you didn't have that is in the next slide. And here's just a quick command as far as showing how you could easily copy this to your own data scratch directory, which I'd already done before. Basically, do not run scripts there directly, run from your scratch directory, and you never run the run commands, always use the setup. So that basically make sure maintains that your Slurm jobs are being queued and will process, especially if the node's busy with other users. And here's just some of the details of that script I showed there before, using one node unless specified, some example output paths of what the results would look like. If you give the arguments of some before, it would look something of this effect. If you didn't, it would look something, it would automatically use one node and give you a month, day, year, time. Let's see. Our wrapper. Sorry, just was going to quickly look at the chat. All right, so the wrapper script details for the pre-trained setup. Again, the thing that you really want to pay attention here is your SBATS command that you're using. This is how you basically tell Slurm that you're working with RDU, and the number of RDUs that you've requested for one node. As it's been said in other presentations, you have up to 8 RDUs that can be used. And the number of tasks are specific to the model architecture, where it can be slightly different. For our Llama 13B example, it will basically take advantage of 16 workers, if granted 8 RDUs. If you only use half the node, you would have 4 there, and then your number of tasks per node would be 8. And the last thing, as I've already kind of shown, is what that would look like if you just use the scripts as is without changing anything. So wrapper script details 13B, Modbot pre-training record. Another one of the highlights from the script is basically how it has some of these tools we've developed to just verify that the node's working and running as expected, before the job is ran and afterwards. So this is an automatic feature of these wrapper scripts, and it's just good practice to do. Here these are the export of the variables that you have. This one basically showing where we've stored the checkpoint on both, on our system, and you can expect something very similar for any other model box that you've ran, as well as you're specifying the data set they're using and what it would actually look like on your system, where you could find it on your system. And yeah, as I kind of noted before, there's kind of 2 big output directories that you need to be cognizant of when you're working with these scripts. One is your outdir, which has a lot of the information, and then your other one being your output path, which shows the results of the Slurm job. And then the outdir here will actually have your results of those Slurms, Slurm. The output path shows how the job is running, and at the outdoor location, you can also find your tokens and anything else that you saved. Some other important variables here, going back to when we first said that there's user configurations. These are some of the variables and things that can be changed and used the within the user configuration before you execute the scripts. The outdoor location can actually be changed. This particular is exactly where you'd find your tokenizer inside your outdoor, in a folder directory called output, and where it was ran. For this particular example, your max steps, your log steps, your learning rate, warm up steps, save steps, step and run. So you can technically change these. It's especially not. I wouldn't recommend changing the learning rate. As far as this is what the model expects, but you could do a different configuration and you do a different learn rate, and then these are completely changeable and can be just up to the user as far as doing, 8,500, doing 10 steps, doing 100. And then there are basically paths that are inside of the model box. So you can actually refer to them there, and you can also refer to them outside of the model box. And you can use this if you generate your own paths to basically be able to attach these to mount these to the model box and use these instead of what's been provided to you. This is another highlight of the pre-train run as far as the rsrun command, as well as the execution of the singularity image container, and this is our actual Python command that runs our model and some of the flags related to it. The flags vary in nature from something model specific to a unique parameter or uses that just for SambaNova. And as it was referred to yesterday, a lot of the, like, we can think of the Samba flow as just a thin, basically a thin wrapper around your PyTorch, existing PyTorch models. So the flags here should all look very familiar and something that you can expect to see in a PyTorch model if you run those. Let's see, I am doing okay on time. All right. So for the fine tuning, again, by design, all these scripts have a very standardized way of processing and being used. And as such, the once you've learned how to do the pre-train, the fine tune is going to be the same procedure, and you can expect similar things. Here we can see basically for our SBATS command, instead of using the entire node, we're only using about half of it. And generally that is due to the nature difference of computational resources needed between training a model from randomly initiated weights versus fine-tuning a model that's already been pre-trained. And then in your 13B model box fine-tuning run, uh, the same checkpoint path for starting out here that can be changed, and then our data set from Superglue being used. And one of the parameters that's unique here, we can see there's a different learning rate for fine tuning than there is for pre-training. Yeah, and then lastly, we just have our inference script. You can specify checkpoints, prompts, or inferences. You can start from a different checkpoint of your trained model. We have our data path, and then here there's a particular path that's been uniquely optimized for use with inference. And I basically specify it here to make sure that's used to have the best training. And this is our full Python command. So in the sampling and seeding that can be changed, such as very commonly seen parameters, such as your sampling, your top P, your top K penalties. And then to quickly go through. Yeah, so sad. So, see, could fix that. I might do that, given that I have a little bit more time. Um, we're going to go ahead and kind of look at some of the output results. So here you can see some of the other work that I've been doing from the C node, some of the other things I've been testing. And we are just going to basically really quick. So these are some of the results that you would see if your model was running successfully. And I can't say I'm proud, but you guys can also see as far as how it is when it's not working, and we might just spend some time troubleshooting that. What you can expect in your Slurm output files. So in essentially specific locations of how it's been worked on, the output, this shows the output path. Basically showing how the health of the hardware was good before. Output of it before. And actually, let me do how long it ran. And just to show how well it's done. And here's some of the information you can see for the how well it's doing and how well it's done for its training. And this was a very short run, I think maybe 100 steps. I used two nodes to do it, so it's showing me the output files of both the node I execute the script on and the node I got the results. And here we can basically just show that our results from that training. So this is basically a checkpoint that I've made, and specifically there's a checkpoint at step 10. And here's our new tokenizer if we wanted to start from step 10 instead of having to start from the beginning. And particularly, and we would, for our checkpoint path, we would just change that to the name of our checkpoint path. So just want to kind of quickly show that. Um, yeah, and wrapper script details running for an existing checkpoint. And here I just have some details of what that like might look like for your guys' self, and particularly on the ANL system on from node 3 host 1. Um, and yeah, I've gone way too quickly. So